In this video, I'm going to show you how to use extended division facts to find the quotients of very large numbers very quickly. So let's say I wanted to divide 42,000 by 700. And if you've watched my video on extended multiplication facts, you've seen that this is really 42 times 10 times 10 times 10. And this is really equal to 7 times 10 times 10. So we have 42,000 divided by 700, just written in a version of expanded form. Now, unlike multiplication, the commutative property does not apply to division. So we have to do things in the order that they are written here. So I'm going to start with dividing 42 by 7. 42 divided by 7 equals 6. And then I'm going to start dividing my tens. So I have 10 divided by 10. 10 divided by 10 equals 1. So when I divide those two tens by each other, they're basically canceling each other out, because whether I multiply this 6 by 1 or divide it by 1, it stays as a 6. So these tens, I'm just going to mark out. They cancel each other out. My next tens, I have another 10 and divided by 10, so that does the same thing. And then lastly, I have one more 10 that's not divided by anything, so that last 10 has to be multiplied by the 6, so I'm going to put a 0 right here as a placeholder. So my answer is 60. I'm going to rewrite this to look like a fraction so you can see a little bit better what I just did here. And fractions are the same thing as division problems. They're just written in a different format that we're used to. So what I really have here is 42,000 divided by 700. So when I started my division, I did 42 divided by 7. And 42 divided by 7 I can do, so I canceled that out and I exchanged it for a 6. The next thing I did is 10 divided by 10 right here. Again, I can do that. 10 divided by 10 is equal to 1. I have another pair, 10 divided by 10 right here, which again is equal to 1. And then lastly, I have this 10 right here that's not divided by anything because everything in the denominator of my fraction has now been canceled out. So altogether across the top, I have 6 times 1 times 1 times 10. So 6 times 1 is 6, times 1 again is still 6, times 10 is 60. So my answer is 60. When you get more experience with fractions, you'll be able to go ahead and do that division by 10 right within the fraction by doing 10 divided by 10, 10 divided by 10. 42 divided by 7 right here is 6, with this 0 right here still with it. So my answer is 60. Let's look at another example. Let's say I have 6,300 divided by 900. I can think of this as 63 times 10 times 10. And I can think of this as 9 times 10 times 10. Again, with division, the commutative property does not apply, so I must do things in the order that they're given. So I did 63 divided by 9 first. That gives me 7. And now I'm going to have 10 divided by 10, which is 1. I don't need to put that in my answer because no matter what I do to the 7, either multiply or divide, it's going to stay the same. Same thing, 10 divided by 10 is 1. So I have nothing left to do in my problem. My answer is 7. I can rewrite my problem to look like a fraction and do my division directly within that fraction if I want to. 10 divided by 10 is 1. 10 divided by 10 is 1. And I have 63 divided by 9, which equals 7. Here's another example. Let's say we have 45,000 divided by, let's do 90. This is really the same thing as 45 times 10 times 10 times 10. This is 9 times 10. So my problem becomes 45 divided by 9, which is 5. And now I'm ready to cancel out any tens. 10 divided by 10 is 1. And I have two tens right here that are not canceled out. So they are going to be placeholders in my solution. So my answer is 500. I can write that as a fraction and do my canceling, one more zero there, and do my canceling out directly in my fraction. 10 divided by 10. 45 divided by 9 is 5. And I have these two 10s left that are not divided by anything. Now, realistically, when you start getting better at these, when you do these problems, you're never going to write out all those factors of 10. You're going to look at your problem like this, and you're going to go like this. 10 divided by 10 equals 1. 45 divided by 9 equals 5. 1, 2 more zeros that I need in my quotient as placeholders. Let's look at one more example. So this one will be 6,000 divided by 120. And this one might not immediately appear to be an extended division fact, but if I look a little bit more closely at it, 60 divided by 12 should be a division fact that you're familiar with. So 60 divided by 12 is equal to 5. Now I can divide my 10s. 10 divided by 10 is 1. And I have one more 10 right here that is not going to be divided by anything, so it becomes a placeholder in my quotient. Now you might be thinking that I forgot about this 10 right here in my dividend, but remember this 10 here was part of 60 divided by 12 equals 5, and that's why I always underline the original base problem that I do to remind myself which of these digits I've already used, so I don't get lost in trying to just count a whole bunch of zeros here and then accidentally duplicate things in my quotient.